Okay, so this video we are looking at the various data types that you get, particularly within Python, with a little hint of looking at generally across programming languages as a whole, and then starting to look at how we might iterate or kind of loop through some of those, particularly where we've got things like lists that we might want to deal with. So let's start off just by having a look at the different data types there are, and it kind of looks like there's an awful lot there, but generally speaking, there's only a few that we use more frequently than others. So strings we use quite a lot, numbers that go into, and there's two types of numbers. There's whole numbers, which are integers, and we've got decimals, which in Python and most other languages we call floats. We have Boolean types, which are true or false, and we have lists and dictionaries. Okay, we'll look at those in more detail in a moment, but let's start with strings. So strings are one of the most kind of common and simple forms of data within any language. Okay, strings are just a combination of letters, numbers, spaces, punctuation, whatever it is that you're doing. When you are programming, if you're writing a string, it needs to be encapsulated, so surrounded by speech marks for it to be used. And actually, numbers can be strings. So if you put a number surrounded by those speech marks to make it into a string, you kind of have to think of it as a letter 2 rather than it being a number 2. If you try and put it together with another string, it will actually add it to the end of the string rather than actually adding 2 on. So if you had two number 2s, for example, both are strings, or one was a string and one was a number, if you use the plus sign to merge them, to join them together, rather than adding them as 2 plus 2 equals 4, it would add them as kind of letters, so it'd be 2 and 2 again. So you'd actually get 2, 2, which looks like 22, but it's actually just 2 letter 2s. And as you just mentioned, you can push two strings together. You can merge them together by using an and sign to merge them. Numbers, again, fairly simple. We have integers, which are whole numbers, and decimals, which are floats. When we use numbers, we don't need quotation marks around them. In fact, you shouldn't use quotation marks around them. Otherwise, they will be treated as strings, so you wouldn't then be able to do maths on them. If you leave the quotations off, though, they are treated as number, which means we can start doing some mathematical operations. The most common being plus, minus, divide, and times. And quite simply, you can do 2 plus 2, and it will return the answer 4. So we've got plus, minus symbols are normal. Divide, just in case you haven't used it before, is a slash. And for times, we do not use the X letter, we use a star, which is like capital 8. Okay, so we use the star for a times. If we do put those speech marks around it, like I mentioned a moment ago, so if we merge a number and a string together using concatenation, it will just add it to the end of the string. So even though it is a number and it has a plus sign, if it is anywhere with a string, it will be treated like a string. So in the example there, hello, in speech marks plus 2, which is a number. It's got no speech marks around the 2, but because it's being added onto a string, it itself will be treated as a string, so it will give hello 2 as a string as a whole. So Boolean, possibly the most simple of the lot. It's either true or false. Really useful in programming when you're trying to just say whether to do something or not. Is something true or is it false? Okay, and it's used so many times. Most commonly, it's used in conditions. So if something, then do something. If it's true, then do that. Or if it's false, do something else. Okay. So then we get on to more kind of complex data, so lists of items, when we've got more than one item and things like that. Now, in its simplest form, a list, if you imagine you're going to the shops and you're creating a shopping list, you write down, I don't know, baked beans, breakfast cereal, tomato ketchup, milk, bread, and so on. They would just be on a list, okay? And they're very simple things. They just one item on a list. In the example I've given here, I've got some colours. So I've got black, white, green, blue, and red. Now, it is simply just a list of those items. There's no properties to them. They're just one item at a time, treated independently. Now you'll notice that they are encapsulated, they are inside square brackets to designate that it is a list. And because the colours I'm using are strings, they need to be surrounded, each one needs to be surrounded by speech marks. So black as an item is surrounded by speech marks because it's the word black. I put a comma to separate it from the next one, and then the word white is the next item in the list with speech marks around it again because it is a string. You can have lists of numbers, so it could be the square brackets and 3, 4, and because they're numbers you wouldn't need the speech marks around them. So those items in the list can be of whichever string or number data type you want. The key thing is that they are start and end with a square bracket, and each item in the list has a comma in between. If I wanted to access an item in a list, if I wanted to pull out one of the colours, I can do so by using the item's index. Now, indexes with arrays or lists, they start at 0. So it counts up 0, 1, 2, 3, and so on. Okay. In the case of the colours you can see on the screen, black would be 0, white would be 1, green would be 2, and so on. So if I wanted to access one of those colours, for example, I can use colours, and in the square brackets next to it I can put the number 3. I would start up at 0, so 0, 1, 2, 3, so black 0, white 1, green 2, blue would be 3, so colours, and then the number 3 in the square brackets would return the colour blue. Likewise, if I did colour 0, that would be black, because that would be the first one on that list, the 0 index. So the key thing with lists are that they're just simple items, one thing in each box. There are 2 other types, kind of like lists. So we've got sets. They're very much like lists, but there's a few key differences. So they are fixed in order, so they don't change in order once it's been set. And you can only have one of each value. So you could have in the example there, I've got 2, 4, 6, but I couldn't have another number 2. You can only have one of each value. Tuples are very similar. Again, they're kind of lists, but once they are set, they can't be changed. So in the example below, in the rounded brackets, we have 18, ABC, and 25. You can't rearrange them, so they wouldn't change in order, they wouldn't change the values or anything like that. They are set, and they're really handy for sending properties to functions and things like that, where you need to know the order, that the first property is the thing that is, I don't know, the length of sides of a shape, or the number of sides for that shape and things like that. So they're designated in round brackets. Sets, we just mentioned a moment ago, they have the little braces, the little kind of curly wiggly brackets around them. Okay, and we'll see a particular type of set in a moment called a dictionary. Okay, and they're just they are a kind of a form of set, but have a few extra little properties to them. So having talked about dictionaries, let's have a look at them. So in some languages, like JavaScript, they'll be described as objects. In Python, they're a type of object, but they're a particular one called dictionary. They have those curly braces to start and finish, and they have a set of key value pairs. And each one of those key value pairs is separated by a comma. So if you look at the example, the first example, I have a car. That has many, many attributes to it. I've just picked out a few of them here. So that car may have an attribute of the make of car. And the make, its value of the make is Tesla. I could have model. So that model of the Tesla car that I've got is a Model 3. So these things come in pairs. So you have the make, the key, which is make, colon, and then the value next to it. So the make has the value Tesla. I put a comma, the next bit, model, has a value Model 3. Again, colon in between. Because I'm dealing with strings, I have speech marks around those strings, and before I start the next key and value pair, I need a comma. So then I have a comma, I have another property here called max speed, colon, and then the max speed is actually measured in numbers. In this case it's miles per hour, but I'm leaving off the unit and just having it as a number. So it is a number 162. Don't need speech marks around it because it's an integer, it's a whole number. And then the range in this example is 374 miles as an example. And again, it's just another key value pair. One of the key things with dictionaries is you can't use the same key twice. So a car, for example, can't have two makes. In this case, it's a Tesla. It can't be a Tesla and a Ford or whatever. I can't have two different max speeds. I can't have two different models for it. You can only have one property with that name. So if you've got a property for a model, then you can't have another one later. So in some cases, you might need to list several of the same property, as it were, and that's where you might have something like a number going up. Examples might be, I don't know, your teachers, your form tutors. So in some cases, you might share a form teacher. So you might have teacher 1 and teacher 2 would be the two keys. Okay, but they do have to be different. So we've got this this dictionary object. We've got the various keys and values to them, and we can simply access them by putting in the square brackets the key that I want to access. So in the example above, the variable is car, and I want to access the make. So I have car, and in the brackets I put make as the key that I want to do, and what would be returned is Tesla, which is the make that was put against it. In the example for max speed, I put car and in brackets max speed, and it matches what the label, the property name that I gave it, including whether it's capitals and lowercase. So if I did max speed with a capital S in this case, I need to make sure it's the same below. So they are case sensitive. But if I did that, it would return the value that was the max speed for the car, which is 162. Now, if we look at some examples, so an example of a dictionary is a single top trumps card. In this case, I've got a top trumps card for the Hulk. His name is the Hulk. And then we've got some values underneath. So we've got things like the debut year, we've got a number of appearances, special powers and cunning and strength and technology. And each one of those is a key and value pair that goes in that dictionary. And you can see the example of that dictionary below, that it has a name value, which is the Hulk. I have a debut year, which was 1962. I have appearances, 4,870, and so on. Okay, each one of those key value pairs is separated by a comma, and the actual key and the value have a colon in between. Okay, once we get our heads around that, it's really straightforward. You can see the Hulk, because it's a name, it's a string, has speech marks around it, but the other ones that are numbers don't, because they are numbers, they don't need speech marks. So taking it that little step further, a dictionary is a very simple single item. But what we can actually do is mix lists and dictionaries together and have a combination of the two. So in the top trumps example, if we take it a little step further, we could have a set of top trumps. Now, I've only got 3 on the screen, but you could have, you know, a deck of 20 or 30 or however many you want in those top trumps. But we have got a list of cards. In this case, we've got Captain America, the Hulk, and Spider-Man. So that list would be in the square brackets, and then we'd have something for the card 1, comma, card 2, comma, card 3, and so on. And I've just coloured them to try and help you see that which bit goes where. So you can see in the code at the bottom, we've got the white brackets and the commas in between each of the items. Card 1 is a dictionary like we had on the previous slide for the Hulk. The first one is Captain America and the attributes, the properties and attributes that go with Captain America. I have then a comma, it goes red, and then I've got the Hulk. Then I've got a comma, and then I've got the kind of the bluey green one, which is Spider-Man's details. And it's really simple. We've got that list And each item in the list, yes, it's only one thing, but that one thing is a dictionary. And we've got comma and then another dictionary, and each one is only one item, so it is still a list, but then we have extra details within that single item that makes it, that is the dictionary. So let's move on. So in the programming, we've got all our strings, we've got maybe numbers, we've got lists, we've got dictionaries and so on. So quite often though, we might want to go through and systematically go through things at once at a time. So we use loops to do this. So we'll go through each item, and the basic syntax of a loop is using for something in something. When we use for and we can have a variable name, and that variable name can be anything you want. It can be a single letter, it can be a word, whatever you want it to be, but you just need to make sure if you want to use it later, and we'll look at how it gets used later, but you just make them match. So if you've used X, then you use X later on to use the item that you've got up to. So we use for, we get the var name, and then in, and then we have a set of items that we want to go through. Now it could be we want to go through a certain amount of times, and we can create a little kind of list of numbers using the range function, but we'll look at that in a moment in a specific example. But basically what happens is we go through, we've got for, the var name, in, and then the items that we're going to go through. We have a colon to show that we're ready to move into that loop. And then as we go down, we then have to indent. So we need to make sure, because these happen within the loop, that they are indented in so that it signifies that it's inside that loop. If I want to do something after the loop is finished, I need to come back out and match up with the same line. Remember, Python is organized by how things are lined up in terms of indentation, even down to the point where even kind of one space extra at the start of a line can throw an error. And you might see it quite often in your kind of error logs when you try and run a program, and it will say indentation error. Okay, but that's what it is. So things have to line up. In this example, I've got the for var name and items colon, and then I go to the next line, I've indented in, and all the items I want to do while it goes through that loop are inside, pushed in. Once it's finished, it comes back out, and in this example, it's not proper code, but it's just going to carry on after the loop. So let's look at a few examples. So if I want to loop through a string as an example, I've got some code here on the left. So first of all, I've assigned the string to a variable. So my variable will call my str, and in it is the other words hello world. All I want to do is go through each letter one at a time, and in this case I'm going to do something really simple. I'm just going to print each letter in the output one at a time. So I'm going to use the for, my index, my variable name, I'm just using the letter I. It doesn't really matter. So if I was using the letter X, if I was using letter as the word or something like that, I could use that there. But later on, when I use my str and in the square brackets, I just need to use the same word, letter, whatever it is that I use. That will represent the number we've got up to. Okay, so it starts at 0 and it goes up. And the number we need is actually how many letters there are in the string. So you'll see in the blue, I've got a little function at len, which returns the length of something. So in this case, we're going to return the length of the string. It counts up how many characters, including spaces, are in the string. So that gives us a number. But what we need to do to actually loop through is actually have a list of, in this case, numbers. So we use this range function, which actually turns a number. So the length of hello world is 11 characters. That blue len my string will return the number 11. And what the range does is it says, right, I'm going to create a list of 11 numbers starting at 0. So it could be 0 to 10, because 0 counts as the first one, 1 is the second, and so on. And I want 11 numbers in total. So 0, 1, 2, 3, all the way up to 10. So it will go through each time. I will start at 0, then 1, and then 2, and so on. So each time it goes through, as we mentioned earlier on, we can access lists or arrays by using the square brackets and the number inside. We can do the same thing with strings. So if I did my string 2 above, the capital H would be 0, E would be 1, and the first L would be 2. Okay, so my str in square brackets 2 would return an L. So as we go through the loop, I counts up, it goes 0, so it'll start off the capital H, finish that part of the loop, go back up again, then it'll be number 1, it'll do the E, then 2, L, and so on. It will go through each of the items in that string and return the letter or character, whatever it is. It could be a space, it could be a piece of punctuation, whatever it is. It'll return it, and print just shows it in the output of the program. Looping through lists is actually more simple than going through strings, because we don't have to worry about the length of it or anything like that. We can use the for again, but in this case, the variable name I've given it is col, because my list is of colors, so I'm just going to say col. It makes sense to me for the variable name. And I use in, and I can just simply put my list, because actually what it will do is already a list of items to go through. So I don't need to create a list of numbers to count up or anything like that. I'm just literally going to put the list. So I go for col in, and my list is the name of the variable that my list is in. Each time it goes through, each of those values in the list is going to be put into col. So quite simply, I can do print, and in the brackets, the value col. So it'll go, first time round it'll be black, then it'll go around again, then it'll be white, then it'll be green, it'll go around again, blue and red, so on. Looping through lists is super, super easy. It's learning that 1 line. One of the key things, or the main mistakes, people forget the colon at the end, like we do with all of these for loops, and forget to indent, or when they finish what they want to do, they forget to come back out again, and whatever they kind of keep going on is actually looped through as part of the loop. So remember that indentation shows what you're doing each time you go through each kind of part of the loop. So dictionaries are a little bit more complex. So dictionaries, we can still use the for loop. We can still use a variable name. In this case, I'm using the K. Again, it doesn't really matter what you call it. I'm using K because the key and value pairs, I just think of K being the key, and then we'll get the value out in a bit later. So in my mind, K works for key, but it could be anything you want. It could be P for property, it could be a word, whatever you want it to be. But just make sure when you're using it later that it matches up. So in this case, I've got a variable called my dict. So that is a dictionary. I've got the same one as earlier on. So I've got that car. So it's got a make, it's a Tesla model, it's a Model 3, max speed and range and so on. And all I'm going to do is go through. When you loop through a dictionary, it just goes through each of those key value pairs, and the key is put into the variable that you set. So make would be K, then it will go on, next time around, model would be K, next time on, max speed would be K, and then the next one, range, would be put into K. So in the below example, for K in my dict, don't forget the colon, we go down, we indent. The first line, print K, will print make, then it'll go round. Next time round, that print K will print out model in the output. Next time round, it'll print max speed. Okay, so we've got, for the first time round, we've got make. The next one says print my dict K, so it's going to look at that array and it's going to look, and in the square brackets I've put the key. So first time round, K is make, so it's going to look in my dict and look for the make, which is Tesla. And then the bottom one, all I'm doing there, and it looks a little bit complicated, but I'm just concatenating, I'm merging three strings. K, which is the key. So the first time round it's make. I just made a little arrow out of a minus sign and a right chevron, and I've got the myDict_k, which is the value. So it should give me the make, arrow, and then Tesla. And then next time round we go round, it will be model, arrow, model 3. So those three things happen one by one each time it goes round. So it will be, for the first time round, it will go make, which is print K. Print myDict_k would be Tesla. Print K plus arrow plus myDict_k would be make, arrow, Tesla. Then it will go round. The next one is model. So it'll go print K is model, print myDict_k is model 3, print K plus arrow and so on will be model, arrow, model 3. And it will go through all four of those properties.